Good afternoon, everyone. My name is Guevara, and I'm going to present you this work titled Open Architecture for Wireless Sensor Network based on Runtime Reconfigurable System and the IEEE 4051 standard. This work was developed by the Catholic University of Asuncion and the University of Sevilla in Spain. So this is the outline of the presentation. First, I'm going to present the objectives of this work. Then I'm going to present the IEEE 4051 standard. After that, I'm going to present the proposed architecture and the Flora project. This project was made in order to test the architecture that we are presenting here today. And finally, I'm going to present some results and future works. So, as you know, wireless sensor networks have many applications like telemedicine or domotic or environmental monitoring or structural health monitoring or military applications. But usually in these applications, the sensor nodes are made in an ad hoc solution which bring a low level of flexibility. So even if the applications are very similar, usually you cannot reuse the same sensor node for different applications. And especially in wireless sensor networks, where the sensor nodes are very connected to the application that was made for. That's why we try to propose an open architecture that use some common device used in wireless sensor network, but that is based on an international standard in order to ensure the compatibility in different applications. And also, we want to add some reconfigurable hardware, and of course, we want to do all of this maintaining the low power consumption because that's a very important issue in wireless sensor network. So, some characteristics of the proposed architecture, first is that can handle heterogeneous sensors. So you can put different kind of sensor for different applications. We base it on an international standard to ensure the compatibility in different applications, and we add reconfigurable hardware in order to increase the flexibility of the sensor node. Well, the standard we use is the IEEE 4051 standard, and the goal of this standard is to allow the access to the data transducer through a set of common interface, whether if the sensor is connected wired or wireless mean. So you can have a sensor that can use Bluetooth technology, another Wi-Fi technology, another 6LoWPAN, or your own protocol, and you can interconnect all these sensors in a one network. To do that, the standard defines two major components. First, the NCAP that works like a gateway between the sensor network and another class of network like internet, for example. And the second is the transducer interface model. In this transducer interface model is composed by the transducer or actuators, the conditional circuit, and another important definition that brings the standard, that is the transducer electronic datasheet. This called TEDS is a memory device attached for each transducer that contains several information about the sensor, like what kind of sensor is, the sensor ID, calibration data, and many other kind of information. So we use this standard, and like I said before, we want to also use some reconfigurable hardware. And to do that, we use this PSoC device. This is a programmable embedded system on chip. So this device contains several digital and analog blocks configurable, a memory, and a microcontroller on a single chip. So as you can see in this graphic, you can easily connect the digital system. First, you can easily configure the digital system to make different kind of interface, for example. You want a USB port or a serial port, you can do it with that. It's hardware. If you want analog block, you have many digital filter block, or you have operational amplifier or different kind of ADC. And you can connect this easily with the CPU and with the I/O ports. So you can make different kind of circuit conditional and different kind of interface. So the proposed architecture is like we can see in this figure. We want to that PSoC is in charge of the reconfigurable hardware. The PSoC is in charge of the analog block of the, for example, the filtering stage and circuit conditioning. And we let that the IEEE 4051 standard manage all the wireless sensor network. In this case, in the project that I'm going to present, we use a TelosB platform modification. So this TelosB platform runs TinyOS, Tiny Operating System. So you can put whatever your network protocol that you want. So because in wireless sensor network, everyone's try to do their best network protocol. So you can do that. You can prove different kind of protocol, but because it's based on the IEEE 4051 standard, you can connect between them. So it's important to say that the IEEE 4051 standard doesn't manage reconfigurable system, but like it's an open standard, we add a new text, a new electronic data sheet that represent the hardware architecture that you want to put. So with this text, you can put different kind of circuit conditioner, like in this figure. And we use a PSoC device 1. So this is limited to 8 different kind of preload configuration. So you can do one configuration, for example, for all digital sensors, another for all analog sensor, or another for mixer sensor, and you can change between configuration on the fly, very fast. Well, and to put this in test, we make the Flora project. This project implements an environmental sensor network in the area of the Itaipu hydroelectric dam. As you can see, this is some screenshot of the website of this project. We deploy several and different kind of sensors in different parts close to the Itaipu hydroelectric, and we measure some variables like temperature, humidity, monoxide of carbon, and others. And in the website, you can see in real time the measurement that they are taken. This is some prototype that we implemented. As you can see, it's a TelosB platform based, and here as the PSoC one is a very prototype. And like I say before, this is an example. For example, you have first a blank digital block, then you want to change it with another functionality, special functionality. Well, you can do it. You can do it very fast and on the fly. You don't need to go there and change this hardware. Some experimental results. We make some network commands. For example, we can make a route like a sensor like a router or like an envelope in order to save some battery. And we have hardware commands. For example, we can enable or disable the monoxide and dioxide carbon sensor because the gas sensors are very high consumption of power. So we can do it to save the power. And another experimental result, well, the average time of the life of the sensor was of 6 months. We only use 2 common batteries of 1.5 volts. I know that it's not so much, but using this kind of battery, we think that there are some okay. And you can see that the reconfiguration time in the PSoC device is very fast, is in order of milliseconds. So you can you don't have to worry to lose some measurements because it's very fast for this type of applications. Well, so in the future work, we want to compare the proposed architecture using different kind of protocols. For example, the cyclopam. we want to implement some energy harvesting, and we want to use a similar reconfigurable device like FPGA of PSoC 5 of FPGA in order to prove another kind of devices, reconfigurable devices. Well, that is all, and thank you very much for your attention.